Welcome to the Friday Transportation Seminar at Portland State University. My name is Chris Monsieur. I'm a faculty member here in Civil and Environmental Engineering. And together with my colleagues Rob Bertini, Jennifer Dill, John Glebe, and Miguel Filiozzi, we co-organized this Friday Transportation Seminar. We're very pleased today to have Dave Crout from Trimet to talk to us about ITS applications there. So with that, take it away, Dave.
Well, good afternoon. Just real short, before I get into the presentation, I just want to say what I do at Trimet. I pretty much spend a lot of my time analyzing the data, the rich supply of data that we get from our bus and rail location data or systems that I'll go into more detail. And there's almost like no end to the things we can do with the data, and we can slice and dice it all kinds of different ways, and we get a lot of requests internally and externally. So, but today I wanted to go into a little bit how our automatic vehicle location system works and what kind of data and data products that it provides us, and also spend a little bit of time explaining how our real-time bus and train arrival information, also known as transit tracker, how that works in some of the different components of that we have. Also going to touch a little bit on the transit signal priority system we have, and our latest project, the automatic stop announcements in the buses. So in a nutshell, the automatic vehicle location system starts with what we call a data card, or what we also known as bus dispatch system, BDS card, we call it, that an operator places into a device on board the bus. And that data card has data on the card for a specific set of trips that bus is going to be doing on that day, but it also collects data along the route. And we also have tracked all the buses with GPS. So once the bus goes through its trip, it's collecting data. It's collecting data at different bus stops. How many people are getting on, getting off, that sort of information. Then that data is collected on the data card, and then we download that onto the network. This was state of the art about 10 years ago, but a lot of systems, transit systems, are going to wireless, which we will eventually be doing because there's lots of problems that are associated with using these cards. One of them is they can get damaged, which happened last week, and we lost quite a bit of data. So the data is uploaded to the network, and then it goes through a process to match it to our schedule so that we can then relate it to other data that helps us develop reports. That gets integrated into our relational database, and then we're able to produce reports from that. Also, I didn't mention, please feel free to ask questions during my talk if you wish. So in general, for buses, two types of data that we collect. Stops data, which is automatically collected. That would be something that, like every bus stop. And that's quite a bit of data. It's about 500,000 records a day. And then we also have data that's operator generated. So it's a variable number of records, and that would be something like maybe a fare evasion or some type of emergency, or something that the operator, through that device that I showed, can enter a pre-coded, or a button that has a pre-coded message. So here's most of the records that we get, the types of data that we get from the automatically collected data. This allows us to do a number of things, one of which leads to our on-time performance reports and passenger counts. But we collect quite a bit of information, including the maximum speed of the bus was going between stops, for example, which can be useful if our legal department wants to do some research on a claim. We can look at how many times the wheelchair ramp or lift was deployed, for example. So the automatic passenger counters. I'm just curious, how many of you ride Trimet buses fairly frequently? Okay. Well, as you may notice, or maybe you didn't, but the next time you get on a bus, you can look for these. The little panels there's one there, and then there's also one on that side you can't see in the picture. And this sends a beam across across the doorway, and they're offset beams so that if you're boarding, one beam would be broken, we would know which beam that is, and then if you're getting off, a different beam would be broken. So that's pretty much how we count passengers getting on and off. And there's also a set of these in the back door as well. And about 75% of our bus fleet now has these on them. So we have to do some sampling and some factoring up when we're generating passenger count data. But we figure with 75% fleet coverage, and then those tend to be the buses that are out more anyway. So we're getting a pretty good sample. This is in the bus. It's actually the bus driver sits pretty much over here, and the door is over here. So when you get on, you've probably seen this device. We call it a vehicle control head, and that's where the data card goes into. This display gives the operator messages like on here it's saying schedule okay, route okay, so it's on time. But this is where this is really useful for the operators because it can remind them if they're getting late or early, and then they can. Like if they're get there early, they can control that better than if they're late. But anyway, there's some good information that comes out of there. And then these are the different buttons that they press for various pre-coded information that they send. We have a dispatch center that does for both bus and rail. I'm kind of focusing on the bus here, but the dispatcher for the bus side gets two screens. One is text messages that would be some of these pre-coded messages that would come from that vehicle control head, for example. And then there's also the map component so they can actually see where the buses are. And there's software in here that's designed to prioritize, like maybe it's only going to show buses that are running a certain number of minutes late so that the dispatcher can focus their attention. And if there's an emergency, if a bus driver indicates an emergency through that vehicle control head, that would, maybe some type of a flash or something on the screen to get their attention. So I'm going to go into a little bit of the reports and data products. So this is what we call the card data. This is kind of like in the rawest form, and it's many of the pieces of the data that I was explaining earlier that we have in the automatically collected data is here. I'm not going to explain everything on here, but I was going to point out I've highlighted where I'm just choosing one particular stop. This happens to be the line 14 Hawthorne coming in, going towards Portland in the morning. And so I was just highlighting this one row here, and I have other reports that's looking at the data in different ways. But some of the things I'll point out here is this is the arrival time and the departure time. We also have how many ons and offs. So we had 4 ons and one off there. Some other things here. This is the SPD is for maximum speed, so that's 24 miles an hour between that stop and that stop, for example. So we also know it's an estimated load. I believe it's 16, so there's 16 people were on the bus at that time. This is also known as a time point, so you'll find it in the schedule, and so that's why we have a schedule time for that stop. And this was also a time point with a schedule time so that we can look and see how it's doing. It looks like it's pretty close to on time there. And this is basically the same information after it goes through the schedule match process. That's in a different report, but it's largely the same information. But now we've added route and trip. We've actually connected it to the scheduled trips for further analysis. And then here we're looking at the same stop. This is for one day, looking at that same location, but at different times. So this is how many. If you were to stand at that stop, you would see a bus come by all these different times. And these reports can be really useful when we get complaints and people say that my bus didn't show up. And they say, well, what time was that? Well, I don't know. It was sometime between 7 and 7:30. Well, we can go back and look in here and find out what actually happened out there, and it's really, really handy. And then now we can also look at that one point over a period of time, and this can be really useful to compare. If we're seeing a pattern, it looks like they're pretty much about the same every day, but if we see one where there's one day it's 14 minutes late and the next day is 2 minutes early, we know, well, there's something going on there. But it's nice to have the data arrayed in all these different ways. And then this is more of a summary level. This would be something that we do on a quarterly basis. So this is for the summer quarter, and it's just looking at total rides by different routes. And this is mean boardings per day. So you can see that the max blue line is 77,000 per day, and I don't have this sorted. It'd be interesting to sort this by rides. But some of our heaviest lines, bus lines, are actually not that far below, like the yellow line, for example. Yes.
How do you keep track of it on the Mac?
Please use a microphone.
Oh. How do you keep track of it on the Mac since you don't actually interact with the driver or do that?
You mean on-time performance or what? Or
with boarding. How do you
oh, I see. Yeah, I didn't really explain that. We have a much smaller percentage of the rail cars have automatic passenger counters, only about maybe a third. And so we do just have to do much more of a sampling process to get to build that up. And the operator of the train doesn't really, there's no interaction really between the counts and the operator. It's just automatic. It's through an infrared. It's actually through kind of determining how many people are, how much body heat there is kind of how it works. So. Okay, and then this is kind of going a step further and looking at on-time performance by route. And the way we determine on-time performance is if it's between 1 minute early and 5 minutes late. And so this is just an example of some of the reports management would want to know. Are we getting any better? Where do we need to focus our efforts? And this is the last one here. This is pretty detailed, but this is an example of something that the schedule writers would use to look at kind of historically. These terms up here, this is different service periods. So this is autumn, winter, spring, and summer. And so this is how it's scheduled to take 3 minutes to go from Foster 94th to Foster 82nd. And then these are the different times, the actual times it was taking the bus on those different trips. And so, this is really useful for the schedule writers to look and see. Well, they'll say, well, yeah, I made a change to this schedule, and it looks like, it looks like it actually worked, or no, it didn't work. This over here, median times idle run times, is when we're taking out where we think the operator is deliberately stopping to let the schedule catch up. We're trying to find out, how much travel time was the net travel time. So, because if we don't really know, they could still take them the same amount of time, even if the schedule has too much time in it, and they're what they call killing time. So anyway, that's just an example of kind of a pretty detailed report that we provide for our schedule writers. And this is taking some of that operator-generated data that I was explaining earlier. This happens to be fare evasion. And so since we know the location of where the buses are, and when a button is pressed on the vehicle control head for a fare evasion, we get a lat long for that occurrence. So from that, we're able to map the data. So this is looking at over a period of a month, and it's aggregating into transportation analysis, TAZs, just as a way of kind of aggregating all the different fare evasions. And for illustration purposes, they're shown on here as dots, but one dot could be many fare evasions, so it's really just for illustration. But and then it's by our different districts. So this is something that the fare inspectors can use this information to know where do we need to send our people. And then an example of how we can use that location data. What this is looking at is basically just connecting the dots where the points where the bus lost contact with GPS and then regained it again. So the purple line would be a line between where it lost the contact and where it picked it up again. So if you see a lot of lines that are very thick, then we know that there's a lot of frequency. If we see a long line, we know that there's a long period where they're out of contact. So this is just a way of using that data to help us see if we can see some patterns, and that's why it's on a topographic map here. So try to figure out if maybe we need to add a radio tower, do some kind of radio change to the radio transmission. So, but it's just another example of how we can use that location data. Okay, so I'm just going to get into the transit tracker arrival estimation. And so, we know that we know the vehicle position because of GPS, and then on the for rail, which I didn't talk too much about, we pretty much use track circuits to know where the trains are. The arrival estimation algorithm is depending on both the location and then the what's called the early-late status of the vehicle. And so we know on the buses there's actually keeps track of how, since that data card has a schedule on it, we know where it's supposed to be at a given time. And so if we can determine the early-late status that way. So the bus has, it's either like a minute later, it's a minute earlier, it's on time. So it always has that information with it. And then the AVL system is getting this update about every 90 seconds. So the arrival estimation is pretty straightforward. It's just looking at the how late it is, or how if it's off schedule, and applying that to how much time it should take to get between one point and another via the schedule. So it's really just looking at how it's doing compared to the schedule.
Question.
Mm-hmm.
So why do you need early late to do that calculation? Why isn't it strictly position based? Because I know when the buses are really, really late, you lose your ability to track them. Like during a snowstorm, transit tracker kind of stops working. If it was purely position based, would you have that sort of greater ability to deliver meaningful information or something?
Basically, I mean, there's probably a way to do that, but we made the decision to use the scheduled time rather than try to estimate how long it's going to take from point A to point B. We just look at what's the scheduled time from point A to point B, and then just apply the early late. I mean, some other agencies do it a little more sophisticated way. This is a fairly simple way that, and there are the problems with the snow and ice, but that tends to do more with how far behind schedule a bus is. It starts sending out other messages that kind of cancel out the process. It's kind of not really related to where it is. It would, yeah, if we were able to just look at the location only, that would probably be better. But.
Isn't that partly because that the operators use the early late clock? Isn't that the basis for the early late clock is to show the operators how late it is? So it's like.
Right. Well, that's kind of one of the main reasons why we got the system in the first place, was to help operators stay on time. And so the arrival estimation is kind of something we added on much later. It's built onto the AVL, and that's the same way with the signal priority and the stop announcements. We're building onto what we already have as a way of leveraging what we have. So yeah, it's kind of like it's primarily for the drivers, and we're kind of using that. Mm-hmm.
Do you ever show all the data? Do you ever show all the data to the drivers and get their input on where there are problems, or do you meet with them to talk about it?
Well, yeah, there's different ways it's done. I mean, in some cases, if there's a complaint, there's a lot of complaints, and it actually warrants having the operator sit down with somebody, then with a supervisor, then we could use data to show them that. But more commonly, we just have reports perhaps we post at garage or at employee assembly areas just for them to look at. And and we do, like we have operators do what they call a sign up every service period, where they select what they're going to do, what shifts they're going to actually run, or what trips they're going to run. And we have planners and analysts come and kind of talk to them in that period to kind of explain to them what why maybe they added some time to a trip or not. And so we're using this data in all those processes. We're using this data. So I don't know if that answers your question, but
I was wondering more about you listening to them instead of telling them.
well, in that it would be dialogue when they're in that process. We would getting their input, and then also there's the schedule writers listen to. I mean, that's where a lot of the input that schedule writers get comes from operators in the field. So. So this is how the estimation process is fairly straightforward. And in the ideal world, when the bus is on time, estimates made at 2:50 p.m. and it's scheduled to arrive here at 3 o'clock. So, if the scheduled amount of time is 10 minutes and it's on time, then it would estimate that it'd be there at 3 o'clock, 10 minutes later. But 5 minutes later, the bus becomes delayed. Now, instead of being on time, it's 3 minutes late. So it's basically just adds the 3 minutes to that 5 minutes that's remaining to be 8 more minutes. So now it's going from 2:55 to 3:03. So it's pretty much how that works. And so, like I said before, the updates are every 90 seconds. So that's one of the issues. If something happens within that 90-second period, there could be something that you might get an estimate that it's going to be at your bus stop at a certain amount of time, and then 60 seconds later something happens and the bus is delayed quite a bit. It'll still tell you that it's going to be there at that first time. So there are some disadvantages. So this is just quickly how we, some of the places we have signs on the street that you may have seen. That's near the administrative office on 17th Avenue. So we're pretty much just kind of like, what we're seeing on the bus destination sign, the route, the destination, and the number of minutes. And if the arrival time is not available, we don't have contact with the bus, for example, we'll just show the scheduled time of the next trip.
Regarding that, is that just on a recorded basis, where the 9 minutes remaining? Because I've seen the time where it'll say 9 minutes until the next arrival, but then the next arrival will be maybe 15 minutes. So I'm wondering if that arrival time is it calculating where the bus is at and actually figuring a minute-to-minute update, or
right.
is it just on pre-recorded, like the bus is supposed to be here in 7 more minutes?
No, it's actually looking at where the bus is and then what it's early, late, how late is it, how far off schedule, and that we know from where the bus is over here to this location, we know how long it's supposed to take in the schedule, and so we just we kind of assume that it's going to take that long, and then we get an update every 90 seconds, and it's like, well, 90 seconds ago the bus was basically operating on schedule, but now it's not, and so we're going to say it's going to take longer to get there. So. And we have some multi-lane displays, and we also have them at MAX stations. One thing I want to point out here is we have a additional feature that indicates which train will be leaving next, because this is at Beaverton Transit Center, and sometimes there'll be a red line and a blue line sitting in there, and the blue line is actually it's passing through, and the red line is just sitting there on a layover. We call a layover, and so you might think that the red line is going to leave first, but it's actually the blue line. So. Anyway, that's one feature we added because there were some complaints in the past. And that's downtown at Salmon and Fifth. So here's an example of where we're using the schedule rather than the arrival time. And we have some different kinds of displays at different locations. This is at Kaiser Permanente, and it's look for the yellow line, and we have arrival times here. And this is actually the type of display that we're going to be rolling out in the future for the mall right out here, for example. For those of you that like nostalgia, we have the old mall there, and the old displays. These were actually scheduled times, and I always thought it was amusing that the time on here was usually off by 5 minutes or something, and that's supposed to tell you what time it is right now. So a lot of times those were just blank. So. But anyway, those are gone. And so this is an example of what you're going to see. This is actually at the new West commuter rail in Wilsonville. But this is the type of display what we plan to have on the mall and on the Green Line eventually. And a close-up, you can see we actually have a little streamer at the bottom that's from news from Channel 8. And there'll be some messages on there. And the only thing operating at the time was West, but you should see a whole series of bus arrivals and with MAX mixed in out here on the new mall.
Does Channel 8 pay for the privilege to do that?
I'm not exactly sure how that works. We're we're still kind of working on that since it's not out yet, but on them all yet. But. So I'll just talk a little bit about the transit tracker on the internet, the phone. So a lot of you probably already use this, but this is the web page we have where you can do the same information for every bus stop and every rail station in the system on the web, and just you can access this on the main Trimet site. And so I just happened to choose the 17 Holgate and selected towards 134th and Holgate, selected downtown Salmon and Main, and that allowed me to get a whole bunch of different arrivals at one time. And so this will be similar to what you'll see on those displays when we get those on the new mall. And also, it's handy to have stop ID. That way you don't have to go through a menu of finding your bus stop, and so you can get that by going to this site. And that will give you information on how you can find your bus stop number. And also by phone, we have that as well. And one thing I wanted to show is our statistics are quite impressive here. This is 1 million per month, and it pretty much hit the 1 million mark, I think, in January, last January of 2008, and it just keeps pretty much going steadily here. You'll notice in December, it was that was when we had all the snow and ice, and I first thought was, well, why isn't that higher? But I think there's already so many people using it that it was kind of like people were going to use it anyway. But anyway, it's pretty impressive, over 1.4 million in December. So I think for a lot of people, it's just kind of habit. They just check it before they leave. And also for wireless devices, you can get this on the website. Okay, so I'm going to jump into...
Before you leave the transit tracker, I think you guys should take some credit that you have made this information available to web service so third parties can create applications that do this. And I think there are at least 3 iPhone applications now that display this information in different ways. I've been able to work with some partners, Ride Connection and FreeGeek, and we've actually put things not unlike your flat panel displays in a lot of senior centers that Ride Connection serves. So I appreciate the fact that you guys have made this data publicly available.
And I think there is some mention on our website about that, and I actually looked at what you're talking about, the Ride Connection. It's pretty nice. And also there's a web application where you can do multiple, you can get like multiple stops on one. Okay, so I'm going to jump into transit signal priority. Basically the idea with the transit signal priority was to try to give transit a little bit of an advantage when the buses are running behind schedule, and just enough to where we could try to keep them from getting much later, and also keep the travel times from varying quite so much. So the city of Portland, I should point out this is currently it's only within the city of Portland that we do this, but the city of Portland was on board with us to try to move as many people as possible through intersections. So, but at the same time minimize the impacts on the opposing traffic. Initially, we thought, well, we could reduce transit running times, but actually we found that it's probably more valid in just improving the reliability and keeping the variation in travel time to a minimum, because that then allows us to take out some of the excess time that we have to put into the schedule to accommodate variability. And then hopefully we can not necessarily prevent, but just put off having to add more buses. So the bus, each bus, actually every bus in our fleet now has what's called an Opticom emitter that sends out a signal to an appropriately equipped signal, and the signal comes from the bus only when it meets certain conditions. It has to be behind schedule, and it be within the city of Portland, and the doors of the bus have to be closed. We don't want to be sending the signal if its doors are open, serving a stop. And the bus also needs to be en route. We don't want it to be like when it's going back to the garage or something. So again, we go back to the automatic vehicle location system. This is something we added on to that. And so we know the bus location and its schedule status. So if the conditions are met, then the bus is sending the signal, and then hopefully the signal will respond. Now, not the way the signals are set up, it's pretty much the signal has to have the right conditions within the cycle. I mean, if it's not just going to automatically grant a green. There has to be enough time given to a pedestrian crossing, for example, and there's other criteria. So there might only be maybe 5 seconds or less of green time, extra green time to get through. We're really just trying to get the bus through an intersection. And this is just a little study we did looking at comparing without having signal priority and then having signal priority on a stretch of the line 12. So what this is a distribution of running times, quite a range of running times on this particular line, and we were having to schedule 20 minutes of recovery because of all this variation in run time. And so even though the scheduled run time is 84 minutes, 20 of that was just for accommodating variation to make sure that the driver had enough time to have a break and not so that it's actually running into the next trip. Well, that was without signal priority. And with signal priority, then that distribution moved over quite a bit, and we were able to shave 10 minutes off of that recovery time. So even though the run time, which is only about a minute different, isn't much, there's not a whole lot of savings there, 10 minutes out of a trip for recovery, that's quite a bit of time when you multiply that by all the trips. So that's kind of what we see as probably the best advantage to signal priority. Okay, and then automatic bus or automatic stop announcements on bus. Now, for rail, we've had them ever since MAX was implemented, and but it's a little trickier on the bus because there's so many different locations, so many more stops to deal with, and we were able to not in December of '06 we were able to do external announcements where telling you where the bus is going, basically mimicking what it says on the destination sign. That's a requirement from the American with Disabilities Act that if somebody's sight impaired, that they will know which of the buses, especially when there's a lot of buses downtown, for example, which one should they get on. So that's pretty much, operators are required to do that anyway, but we weren't getting a real high percentage of compliance. So we were under some pressure to do something more. So if the external announcements are done where where a stop has more than one route at it, and we'll see if we have this sound here. I wanted to.
Line 14, Hawthorne, 241.
So anyone who rides the bus would probably heard that before. So so that was back in December of '06, and then we finally, about a year later, started rolling it out to where we were announcing inside the bus. So there's both display of what stop is coming up, and then an audio announcement. And it's not all stops; it's selected stops. It was just too difficult technically to try to announce every single stop. Yes.
I just want to make a quick comment. You said that they had ASA on MAX from the beginning. Because from my understanding, it was not until the west side opened.
It could be. I'm misstating there, but my understanding is that for a long time we've had it on MAX. So this is what the internal one.
Next stop, Gateway Transit Center, Northwest Cooch.
So you notice the first one, it says next stop, and then the second one, it just had the name of a street. And so there's a certain, we try to, some agencies that do this will have next stop for every single announcement, but we thought that was kind of repetitive, so we only pretty much do that when there's, it's something that's not exactly a street. We have a long series of rules for that, but that's kind of why we do that. But in general, we just name the street. street name. But anyway, so kind of the bottom line is that stop announcements benefit everyone, not just those with disabilities. So. And so the display has, we try to put the time, and then we have the street, the cross street. And however, if this is more, if it requires the whole sign to display that, then we would block out the time. It would just, some passengers had said in the past it'd be nice to have time on the bus, so we try to do that. But the criteria, so we announced internally if there's a transfer. Play one of those.
Southeast Powell. Transfer to line 9. Next stop, Beaverton Transit Center. Transfer to Max and other bus lines.
Now at Beaverton Transit Center, since there's so many bus lines, rather than listing each one, we just say other lines. And that's what, when we don't have announcements downtown right now for some technical reasons, but when we do get those going, we'll be the same thing when we see transfer to other lines. So if there's a transfer, we'll announce if it's the first stop on a new street, which is something that's tied in with ADA, because ADA is the intent is to orient people so they know where they are. And so if you once you turn, if you just announce the first stop on a new street, you're basically telling people, well, now I'm on whatever street it is.
Next stop, Morrison Bridge.
So this would be like line 15 going outbound. So that's actually, and even though it might be on the same street, it's a different name. It goes from being from being Alder to eventually Morrison. So, and then also if it's a fare zone crossing.
Southeast 32nd.
Didn't like that. Okay, well, that didn't work, but so that's just another requirement that ADA has. And then we also have stops that are just thrown in there if there hasn't been a stop for a certain amount of time.
Southeast 34th.
And then we just recently did our first, what's called public service announcements. And we're going to have more of those. There'll be things like, leave seats in the front open for people with disabilities, that sort of thing. But our first one, and some of you may have heard this, and it looks like it's not going to work. So it's basically tells you that if you're standing, move back and let others board and use the rear door when possible. So that was something that we actually, I ride the bus a fair amount, and I've noticed that it seems to work. I mean, the first few times that we were doing that, people were kind of like, oh, and then they kind of start moving back. So it was kind of neat. And also the rear door, I think a lot of people are kind of not really sure how it works. So they're, but I see more people doing that now. So that's pretty much it. So, any more questions? Yes.
For low volume areas, has Trimet ever looked into any kind of on-demand scheduling? In other words, I envision people in the future being able to, let's say, who are in a residential area that hasn't got any, commercial area, being able to say, I'd like to go to the store. Anybody else want to go? Log in, pick a time slot, and the neighbors go, oh, I could go then too. A little shuttle bus comes and takes you.
Yeah, I've heard of that. There's some agency in Virginia, I think, that does that. It's kind of like a hybrid between fixed route and what's called paratransit or dial ride. And I don't know if we've looked at that, but that would be something if you wanted to send a comment through the web. That might be something that, or attend one of we have the public meetings right now about all the other service cuts that are going on, but might be a way to get that in there, because that is kind of a nice hybrid, because it might be something that would be cost effective in some situations.
I think that's actually called a jitney, and I think Trimet did a pilot or participated in funding a pilot in the Cedar Mill area a few years ago, and it didn't wind up penciling out. But as technology is changing and it's easier to aggregate the demand through the web or whatever, I think a lot of people are hopeful that'll be a cost-effective technology.
Yeah. Yes.
In your slide with the automatic stop announcements, phase 2, it said 31 routes by March 9th.
Oh, right.
How are those routes determined? How are they, which routes would get that?
We started by, well, one thing I didn't really explain is that we only have the stop announcements on the newer buses, the ones that are the low floor where there's no steps in there. And so the idea was to kind of get those, go to routes that have those buses on there. But we're also looking at routes that carry most people, which also tend to be ones that have those newer buses on there. So it's really just a matter of which ones are going to get the most benefit, but also take advantage of the newest buses. And every new bus we buy is going to have stop announcements on there. And we just got to see, we have 40 buses arriving. I think there's about 10 in service now. And so they're all, they'll all be equipped with stop announcements, and they'll gradually retire the older ones with the steps. Rob.
We have a viewer from Texas who's asking a question about how you measure the success of various features that you've discussed in terms of evaluating their cost effectiveness.
Well, we have a lot of tools to do that. We probably, I'm just trying to think, these service cuts that we've had to wrestle with, that was mostly a data-driven exercise. We had a lot of people from all over the agency met to, looked at the data and looked at other things. So, there's just a lot of different ways we use this. It's different parts of the agency are using the data, and I don't know if that gets at that very well, but yes.
About how many of the signals in the city of Portland are equipped for transit signal priority?
It's about 300. Yeah.
Out of?
About 1,000.
You showed a lot of your data features right at the beginning of the presentation. Since it's been around a while, now you've been looking through the data, what's kind of your wish list of things you wish you had that the buses aren't collecting?
Being able to collect bike rack usage would be nice. And we also don't have a good sense of when we're not able to separate out the front door from the back door, which would be nice, because we would like to see if the effect of that stop announcement, that public service announcement where we ask people to use the rear door, we'd like to see if that's effective. So there's little things, and a lot of that's, at the time we spec'd the product, we didn't think of it, and it's too hard to change now. But we are going to be getting a new automatic vehicle location system, probably it'll be probably implemented in a couple of years. It'll be a very big investment, and so we're in the process now of almost ready to send out a RFP for that. So, things like that would be an opportunity, things we've learned from this system that we want to get in the new system. So hopefully some of those things we'll be able to do. Yes?
I was just wondering, back when you were talking about when you're talking about the AVL data, that you're moving from a card system to a wireless system. Are you still storing the data on board the bus, or were you wirelessly transmitting like when the bus parks or when the actual recording is happening?
The understanding is that the architecture would stay basically the same, where we're just substituting instead of using the data card. The data would be just wireless, so it would be the same thing. We would send the data up into the bus so that it have the schedule information, and then it would be stored on board, and then it would be just transferred down at the end. So it's just basically a more reliable way to transfer. But we would still be using pretty much the same architecture. Now that's the understanding now. It could change with the new AVL system, but for right now we want to keep that the same. So. Yes.
I was wondering how ridership's looking on the West Side commuter rail. Is it as expected, higher, or?
We're running about 1,300 a day, and I believe we had estimated for in a year. It's only been going for a couple weeks, but in a year I think we're looking for maybe around 2,000 a day. But it's pretty early yet. We also don't have the counting methodology is still kind of under review. And we'll have to kind of at the point separate out the kind of like the regular riders. At what point is it going to shake out and be like regular riders. We know the first week we had kind of inflated ridership because we figured a lot of people were trying it out. And we're also trying to figure, people are probably still in the process of figuring out, does it work for them? And we'll probably be making some changes in terms of, like, maybe we won't have the trip, we might take a trip, from the evening and put it in the morning. We might do something like that too. So, but it's been pretty good so far. So.
In terms of automatic stop announcement, in my hometown in Japan, such announcements have been known before I was born. Were there much needs for the announcements from the bus rider?
Well, the bus drivers have been required to basically make the same kinds of announcements. And putting this system in place was really a way to kind of ensure that's happening. I mean, the bus drivers, I think that's a requirement ever since ADA, which goes back to like 1990, have been required to give at least some orientation information. So.
I was just a little bit interested in what kind of input the drivers do put in, and I mean, I think with the signal changing, they don't have any ability to change that. But fare evasion, I heard you say, but I just kind of wanted to know a little bit more about the kind of data that the drivers want to put into the system when that we track. Is that?
Well, I mean, like some of the other things that they can indicate on through the.
Yeah, things that they can sort of change, and part of that is also because when I think of Max, a lot of times the wrong signs are on when I ride and this kind of thing, and so I wonder what actual control they have over the data and what they can actually change and what they can't, and I guess it's pretty broad.
Yeah. Well, okay. Well, for buses, the drivers can change the signs, and sometimes, a lot of times, they'll have to change the destination sign because even though it's automatic and it's supposed to work, it's supposed to be tied in with the schedule, they may have to override that. So that's something they can do. The volume level on the stop announcements, they don't have any control over that. That was a decision we made because we figured they'd just turn it off if they had that choice. Trying to think. And there's a kind of a list of things that they can enter in, like if they see graffiti at a bus stop or something, they can put that in there. If there's a disruptive passenger, if there's in the snow and ice, there was a code for if they're stuck based on whether their chain broke or whether they're actually stuck in the snow, or there's a variety of things like that. But yeah, generally there's there's some things we want them to be able to control because it's important, and there's other things that it's like, well, if they can't affect it, then it's not, it might be a nuisance for them, but it's not a critical thing. So.
Will there be any specific changes to these systems based on the response to last December storms?
Well, we're trying to figure out ways to make the real-time information or the arrival time better, like Chris was alluding to. One thing that we did, anyone who used the system during the snow and ice might have noticed that we provided some distance information. That was kind of the first time we did that. We actually, when you went on and wanted to find out how many minutes until your bus arrives, I think there was a message that said, well, the arrival times are kind of unreliable right now. However, the bus is approximately 5 miles away or something like that, letting people, at least giving them some bit of information to help them decide. It didn't necessarily say that the bus was moving, but but at least there was something there. So, but we are trying to learn. Every time, they're probably not going to have an event like that in another 40 years, but we try to, learn from that, and we've, I guess we've come a long way in what we used to, what we used to have. So, how about back here?
Two quick things about the transit tracker. First of all, I really got to give you credit, since I'm pretty sure you're like the first agency to really do that at such a large scale as provide integration for so many stops.
Thanks.
But during the December storms, I think one of the issue is that it's not really reliable. Even if you're giving the distance, how do you know if a bus is stuck? You know, if it gets stuck, or if there's snow is really bad.
Right.
Not even the operator, no one really knows when the bus is actually going to get there, so it becomes at least partly useless.
Yeah. Yeah. I mean, actually, we are looking at ways to maybe, indicate when a bus is actually, like when a driver's, has said, I'm stuck, I can't go. If that information could somehow get into the system, and now like a little red thing comes up and says this bus is stuck, or I don't know. We're looking at ways to do that. I mean, there's there's a lot of things to learn from that experience. So.
This is like a two-part question. How many rail cars does an average max have? And then my other question is, when ridership increases, can you add rail cars?
Okay. Well, 2 is the most we can have. Most we call it consists together have 2. The new cars that we're going to have that are going to be on the green line, you can only have 2. You can't just have one of those. It's two only. They're limited by the block spacing downtown. 2 is the limit because otherwise you would have a train sitting blocking an intersection while it's serving a stop or serving a station. So no, we can't add capacity that way. We just have to be able to add more trains in, which we still have a fair amount of capacity to do. The trains are going to get more and more frequent, but we still have a little bit of room to be able to do that and still be able to function. And then, of course, adding the new rail down 5th and 6th will give us more room there where we can have a lot of trains, and they won't necessarily be too many of them. So. Any other questions?
There was one last question from an online viewer about whether there are any new security measures applied for the AVL and APC data.
Well, in terms of the privacy issues, or what?
Homeland security.
Okay.
Are we telling terrorists where the trains are?
Oh, I see. Yeah. I think there was some concern about that initially, but it's. I don't.
No, very good.
Yeah, I don't think it's that much of a concern right now. So.
Well, we're going to thank David for his great presentation. Just a second. Sorry. Before we do, though, I would like to remind you that next week, Robin Chase, who is the founder and former CEO of Zipcar, will be our speaker on the topic how sharing and openness should play a critical role in our transportation future. And now, let's thank Dave for his great presentation.